Hello everyone, I am B. Samyukta from CSC department. Today I am going to discuss about principle and applications of UV visible spectroscopy. Here are the outline of the presentation. Here are introduction to UV visible spectroscopy, principles to UV visible spectroscopy, electronic transitions in UV visible spectroscopy, instrumentation of UV visible spectroscopy, Beer-Lambert law, sample preparation and presentation, application in chemistry, applications in biochemistry and medicine, environmental and industrial applications, and coming to the reference. Here are the first introduction to UV visible spectroscopy. UV visible spectroscopy is an analytical technique used to measure the absorption of ultraviolet and visible light by chemical substances. It provides information about the electronic structure of molecules, especially conjugated systems. This technique is widely used in chemistry, biochemistry, and environmental analysis for qualitative and quantitative purposes. Principles of UV visible spectroscopy. The method is based on the absorption of light by molecules, causing electronic transitions between energy levels. When a molecule absorbs light, electrons are promoted from a ground state to an excited state. The amount of light absorbed at specific wavelength is related to the concentration of the absorbing species. Electronic transitions in UV visible spectroscopy. Types of electronic transition include pi to pi electronic transitions, n to pi electronic transitions, and charge transfer transitions. Instrumentation of UV visible spectrophotometer. The main components include a light source, monochromator, sample holder, and detector. The light source usually consists of a deuterium lamp for UV and a tungsten lamp for visible light. The spectrophotometer measures the intensity of transmitted light to determine absorbance. And coming to the Beer-Lambert law, the law relates the absorbance of a solution to the concentration of the absorbing species and the path length. And coming to the mathematical equation, A equals to ECL, where A is absorbance, E is molar absorptivity, C is concentration, and L is path length. This relationship allows quantitative analysis of samples using UV visible spectroscopy. And here are the diagram shows the UV visible spectroscopy how it works. And here are the components we are used to UV visible spectroscopy. They are light source, entrance slit, dispersive element, exit slit, monochromator, reference, sample, detector. In UV visible spectrophotometer we use two detectors to purchase the diagram. And UV visible spectroscopy, sample preparation and measurement. Samples should be prepared in solvents that do not absorb significantly in the UV visible region. Cuvettes made of quartz are commonly used because they are transparent to UV light. Proper blank correction is essential for accurate measurements. UV visible spectroscopy applications in chemistry. UV visible spectroscopy is used to determine concentration of drugs, dyes and other organic compounds. It helps in studying reaction kinetics and understanding electronic transitions. It is also used for purity testing and identifying unknown compounds. UV visible spectroscopy applications in biochemistry and medicine. Quantification of nucleic acids and proteins based on the characteristic absorption. Monitoring enzyme activity and studying biochemical pathways. Used in pharmaceutical analysis for drug stability and formulation studies. UV visible spectroscopy are also applicable for environmental and industrial applications. Detection of pollutants such as pesticides, heavy metals, and organic contaminants in water and air. Quality control in manufacturing processes for dyes, polymers, and pharmaceuticals. Monitoring of waste streams and environmental safety assessments. And coming to the references, Skewch, DA, West, DM, Holler, FJ, and Croach, SR. Fundamentals of Analytical Chemistry, Seeing Age Learning. Thank you. Presented by B. Samyukta.